Boa noite, pessoal. Boa noite a todos. Meu nome é Carlos, eu sou um dos fundadores e CEO do ITuring e eu estou muito feliz hoje aqui com vocês, com essa nossa live, para falar de um tema muito bacana, que é arquitetura sustentável em projetos ágeis. Tá? Eu estou aqui substituindo o Thales, que é o líder da nossa escola de engenharia de software. Infelizmente, ele não pôde estar presente, mas vou fazer o possível aqui para falar à altura do Thales. Né? Hoje é a nossa última aula da série Talk to Experts, onde a gente convida especialistas do Brasil e do mundo para falar sobre vários temas muito importantes na engenharia de software, como microserviços, agilidade, arquitetura de software. E para terminar com chave de ouro, esse nosso último talk, nós convidamos o Joseph Yoder, Joe Yoder, para falar sobre como obter uma arquitetura sustentável em projetos ágeis. Um dos grandes desafios que as equipes de desenvolvimento enfrentam está exatamente em como garantir que a arquitetura não seja negligenciada ao longo do desenvolvimento e entrega de novas funcionalidades aos usuários. Essa e várias outras perguntas super interessantes sobre o tema, o Joe vai responder hoje. Né? Antes da gente começar, eu só gostaria de reforçar que essa vai ser uma fala em inglês, mas não se preocupem. Depois, né, do final da live, a gente vai adicionar legendas em português, mas eu já posso adiantar para vocês aqui, mesmo quem não tenha 100% confiança no inglês, pode assistir, porque eu garanto para vocês que o Joe, como tem muita experiência em ensinar engenharia de software, ele fala muito bem de uma forma que todos são capazes de entender. Então, agora sim, eu passo a palavra para o Joe. Joe, it's a real pleasure to have you here with us. Joe is one of the most respected software engineers in the world, one of the greatest authorities in the topic, and he is gonna talk today about a very important theme in software engineering, which is agile and software architecture in agile teams. Joe, the floor is yours. Thank you.
Thank you, Carlos. Muito obrigado, and bon noite, everybody. Hello, and thank you for that nice introduction. And let's see, I'll share my screen here. If we can get the screen sharing at this point. There we go. And so, first of all, I'm definitely happy to be here again. And hola, everybody. Hello. Unfortunately, I have to give it in English, as Carlos said, but they're going to also do some subtitles and translations later. But I want to talk about sustainable architecture. And I'm very happy to be here. Thank you once again for inviting me in ITuring. And this is actually when I was scheduling this a couple months ago with Carlos and Thales and ITuring. We picked a week that we knew was going to be good for, as some of you might have saw Martin and me doing this. And then I agreed to do something on Thursday, and I didn't even realize that this is Thanksgiving. So happy Thanksgiving, at least in the US. So Black Friday came from Thanksgiving back in the brick and mortars, when everybody after Thanksgiving started their Christmas shopping the next day, and all the brick and mortar stores in the US a long time ago used to have long lines and people trying to get the good deals. Now Black Friday's kind of gone to a lot of other things. And Thanksgiving in general is giving thanks for important things in life with family and friends. And people give thanks for what they have, and friends and family come together, which usually traditionally includes a large dinner with turkey, ham, and much more. And I am actually down. I came down to visit my mother and my nephew down in Texas, and so after this, I'm going to have a big dinner with this. So hopefully, I hope everybody is staying safe and healthy, and I look forward to hopefully being able to visit there at some point again. So I'm going to talk about sustainable architecture while being agile. And a lot of times when people think about agile and architecture, they really don't think of them together. And in fact, if you go to a lot of the Agile conferences, which I've been in Brazil as well as in the US and other countries, a lot of the Agile talks and presentations focus a lot on the people side, which is important. But a lot of times people don't really discuss architecture and that other part. But it's important to really think about that. And as you might have heard from when Martin was talking and had his great story a couple of days ago, is he talked about architectural decisions such as microservices, and microservices by themselves aren't a silver bullet and don't make you agile, but depending on the right application, it made a good business decision for Paxaguru at the time. So as you're being agile, it's important to evolve, and I want to present here within the next 45, 50 minutes some agile architecture practices, how you can be agile in architecture and sustain your architecture. And I collaborated with Eduardo Guerra and Rebecca Wurzbrock on some of these patterns. So I want to give a shout out to them. By the way, you might notice that there's some nice, this is a typical traditional Thanksgiving dinner, which I will be having right after this talk. So I'll make sure I'm on time because I have some family members waiting for me downstairs in the kitchen dining room that we're going to have a feast afterwards. So just to give you kind of a feel of something with that. So just to start off with, there's a lot about how people think about Agile. I want you to at least understand where I come from when I think about Agile. So, a lot of times there's like, is Scrum Agile, or what about TDD or mob programming? You hear about Kanban and Lean. And there's a lot of the main concept with Agile we need to get from the concept, from our ideas, to ultimately to the products we're delivering with that. And most of with the Agile, when it came out 20 years ago, it's been just a little over, this was the 20th year since the Agile Manifesto in Snowbird, Utah. But one of the big focuses about Agile was to have sprints with feedback. You inspect and adapt, and let's get that continuous feedback and make sure we're going the right direction and adapting as we go. And keeping things visible and having transparency. Generally, there's a lot of feedback loops. You have a prioritized backlog and keeping progress of how things are going, and then you can make adjustments. So we don't try to do a big plan up front. We will have a rough adaptive plan with our roadmap, but as we learn and as we evolve and as we're getting feedback, we can adjust and try to do the best thing possible and keep learning, inspecting, and adapting as we go. And there's many different principles and practices. One thing that Agile is definitely focused on is getting good people. So it's with the Agile Manifesto, they really focus on getting motivated individuals with the environment and giving them the support they need. And something else that you see when I think about Agile with the Agile mindset is this continuous improvement cycle. Let's constantly learn, just like anything in life. If I'm a artist, I'm practicing and trying little experiments to see if other things work better. Same way with musicians, and many of my musician friends are constantly doing that. And so let's do and inspect and adapt and try little experiments and try to improve as we go. And also, it's not, the Agile Manifesto doesn't encourage change, it embraces change. So some people think Agile is about just nothing about change, but really let's embrace evolution, business change, and software evolution as needed. And another thing that Agile was committed to is working software, validating proven software rather than detailed documentation. Documentation is important, but working software, they value more than that. And so continuous attention to technical excellence, diligence and hard work, a lot of testing, a lot of Agile principles made the fact that testing and validating, whether you do it with test-driven development or acceptance testing, but validating what we're building for the customers and our users or for our organization is really what we need, and doing that as we go. And being okay to refactor and keep things better with that. And there's also this thing about transparency. We make things visible and have regular feedback and more eyes looking on things. We have regular retrospectives and having that feedback without pointing fingers. And, and technical knowledge is a must. Agile is about having people participating more make all people be responsible for architecture and good design. So for me, Agile is more of a mindset rather than just a blindly doing something. So there's also a lot of myths. So blindly following Agile Lean doesn't give you everything you want. Doing Agile is different than being Agile. So if I'm just blindly doing Scrum and we're having 2-week sprints and daily stand-ups, that's okay. But then I'm kind of maybe stuck in the process and maybe I'm becoming rigid and not being very agile. So one thing you get a lot of myths with Agile is, oh, simple solutions are always best. We call it the KISS principle, keep it simple, stupid. But sometimes simple, we keep it as simple as we can, but sometimes no simpler. Sometimes some of the things we're doing requires a little bit more thinking. And then also people get lulled into, we can always go fast when doing Agile or Lean. We might start off this way because some of the new requirements, and we don't have too much built up yet. We're not dealing with too many different situations. So we can go fast early on. But later on, the customer may come up with a new requirement that looks like what we had before. And it seems to take longer, but that's because we have a bigger system out there and we have a lot of dependencies. And here's another one. Maybe we're following some Agile process, whatever it might be, with sprints, getting that regular feedback, maybe Scrum. And then, we can easily and quickly adapt to new requirements given this. But if we have a little bit of technical debt and some other kind of architectural risk, this can cause a problem. And then there's always this feeling too is, Scrum or TDD or some other Agile process will ensure good design and architecture. Good architecture simply emerges from good development practices. And in fact, sometimes we think we can make significant architecture changes at the last moment. Although this is true, we can make a lot of changes. Sometimes there might be a more appropriate time in making certain changes, like if all of a sudden you have to refactor the system to add a lot of security in, it can cause a tendency to tear up the system, and it might start evolving it to becoming a little bit of a muddy architecture, which can slow down how fast we're adapting to changing requirements. So Agile isn't a silver bullet. Agile is more of a mindset, and architecture decisions, as you heard from a couple of days ago, even with what Martin presented, is important considerations that influence what's going on. So thinking about architecture from the business perspective is important and definitely influences how you think about Agile. So I'm going to present some practices on that. And I want to start out with values drive practices. So what we value and what the organization or the team values will drive what you practice. So there you see me dancing with Mary Lynn Manns, one of the Fearless Change Pattern authors with Linda Rising. And she likes dancing. So she's actually a licensed certified Zumba instructor. So she does regular practices with that. Just like Rebecca Wurzbrock used to run marathons, but likes running a lot. You see her on the right there. There she is. She practices a lot. I remember going to Brazil with Rebecca. We were doing some consulting at Itaú Bank. Even while she was down there, she was preparing for marathon. So she valued that. So it drove her even when she was in Brazil, she would go running around the different parks and stuff in Brazil. And so what we value will drive our different practices. And so understanding and articulating your values are an important part of being Agile. And quality obviously is an important value that most Agile teams have, but also delivering working software regularly and meeting the requirements, but also quality, not only the quality on the outside, what the customer sees, but on the inside so that we could sustain our development. So what we value drives our practices. And I'm going to be presenting a set of patterns that I wrote with these colleagues here that you're seeing. And we're talking about various patterns or techniques. You don't need them all, but, and different practices are about trade-offs. And I want to talk about values drive practices, and regular repeatable practices are what we call patterns. Patterns have been around a long time, even long before software. You see regular repeated practices, but we started looking them software community about 25 to 30 years ago, with different design patterns and things like that. But let's talk about what a pattern is, just for those of you that may not know. So real briefly, a lot of times you hear people talk about patterns have this context, problem, solution, things. When should I think about the pattern? What am I solving? What do I do? But really, you can think of patterns can really be thought of as good practices or proven solutions to repeating problems. Sometimes proven practices to repeating situations. I know those of us in engineering we like to solve problems, but if you talk to a designer, they don't look at, I'm not solving a problem, I'm designing, creating, like an artist is designing and creating something new. So there's some repeating practices for this types of situations that come up. And they embody what works and what doesn't work. And it's really capturing the experiences from that. And so when you really think about it, if it's a repeated type of practice, it can become a pattern with this. And it embodies quality solutions. And if you want more information about patterns, you can go to hillside.net for more information for those of you that might be interested. So let's get into the patterns because, we have a limited amount of time. Let's jump in and move forward with it. So at the beginning of the project, but not only the beginning, you will find things that you can go through this throughout. So while being agile, it is essential to have a sustainable architecture that is able to evolve through the life cycle of the project. Sustainable architectures require ongoing attention, especially when there are evolving priorities and a lot of technical risk and many dependencies. The challenge agile teams often face is how they can start the project fast and still have a sustainable architecture. So a question to be answered on an agile project is how much architecture definition is needed to start development and how to keep the architecture good enough to support the current features under ongoing development and help us sustain that for the long run. So that's what we want to kind of look at there. And when we think about developing something new, there's a lot of decisions. There's always new things going on. How do we keep up? How to handle things and not get stuck? Should we do microservices or not? There's all this hype. Should we do NoSQL or cloud? The Internet of Things, or how about data science, big data, things going on with that as well. And, if we decide on microservices, well, that's building a distributed architecture. And if you're not careful, it can definitely cause a lot of problems. It's not a silver bullet. And sometimes the better thing to build is a monolithic type architecture with good component and design because you have a small set of teams. So what we're trying to do is figure out how to have a sustainable architecture and start the project fast while being agile. So how to balance this. And so our first pattern that we want to look at is climbing on the shoulder of giants. So really, when we're going to start something new, we have to think, where do we start? We're not going to just start from nothing. We have to think about, we have to make some early decisions. So the climbing on shoulders of giants, it really builds on proven architectural ideas. That is the first step you take when preparing to start the architecture. The main idea behind this pattern is to use an existing reference compatible with the application platform and suitable to the application needs as a starting point. In other words, start with something mature that has been proven to work. This can be a reference architecture such as microservices or client-server architecture that defines the main kind of components and how they collaborate to fulfill the requirements. A reference architecture provides a template solution for an architecture for a particular domain. So then you can, additionally, when you're climbing on the shoulder of a giant, there can be reference implementation. That's a skeleton or the frameworks. The reference might be supported by previous projects you've done in your company, software patterns or metaphors that you use. Maybe you have your own frameworks or external frameworks. Could be the programming languages. Are we going to do .NET or Java or Ruby on Rails? Maybe microservices with Node.js and React. Maybe the different databases we're going to use and the like, which provides implementation of the elements. And so really, we think about what we're working on and what's kind of the best reference and set of frameworks that we want to use as we move forward on this. Okay? So we're going to build on this reference architecture. And just as an example, you could think of maybe I'm not promoting Microsoft's Azure IoT, but say we were going to build IoT, we might think of building that, and then we extend it with whatever we need to do for our different types of extensions. So we've decided what kind of reference we need to build on, what's going to be good enough for the types of problems that we're going to be solving or the systems that we're going to be building for our clients or for our customers or things that we need internally for the products and services that we're providing. Now we need to think about, to focus on relevant issues, our next pattern is find where it hurts. So on Agile projects, it's desired to optimize the time spent in initial requirements, especially related to important non-functional requirements. Sometimes we call these the illities that we're not sure about. So Agile teams need to identify what are the risks or the significant threats for failures as early as possible. Without focus, you don't want to try to do everything, but we need to think what are the important critical issues that we need to validate. Especially to find the things that the reference may not work well with, such as access control, or it could be security or scalability. Therefore, when you start the project, find where it hurts. In other words, early on, identify the challenging technical requirements that are important for the project. It is important to prioritize and focus on the important technical requirements that can bring high risk to the project at the appropriate time. So you're not identifying every little detailed things, but you're thinking from a high level, what are the critical things? If we know we're going to have to scale, when should we put that on the roadmap? Maybe we need to wait a while, or certain things might be so risky that we even have a team or two go figure that out at some point. So now we've climbed on the shoulder of giants. We know which reference, and we've looked at the critical pieces that we have. The next piece we want to think about is we need to Agile doesn't say you don't plan. It's just that we plan, but it's a rough adaptive plan, and we adapt it as needed as we learn. So plan for responsible moments, and it's what we're looking at here. And so when we're planning for responsible moments, really what that is, when should Agile teams think about architectural decisions such as performance, scalability, single server or cluster, cloud-based or security, and the like. System qualities and are a key factor in the ongoing success and sustainability of any product. So how can Agile teams include these qualities as part of the roadmap? Most time roadmaps just look at the functional requirements, what we're going to be providing to the customer, rather than looking at the lot. And so people who adopt an Agile mindset generally quote the mantra that no decision should be made until the last responsible moment. Let me say that again, that a lot of people thinking of the Agile mindset, when this gets quoted a lot, don't make any decisions until the last responsible moment. Unfortunately, this sometimes gets misunderstood to be that no decisions are made until the last possible moment, which this challenge is how to address these technical difficulties. And this could lead to tearing the system up quite a bit. And there might have been a more appropriate time to do that. That's why one of the patterns that we put together, and me and Rebecca has really been pushing this, is some decisions and actions are too important to leave until the last responsible moment. So choose the most responsible moment. And so what you can do here is Agile teams plan for responsible moments to know when important system qualities and architectural systems should be addressed while developing and evolving the regular product features. This is done by putting on the roadmap a technical plan for when to handle each of the technical challenges and evolve this plan through the project. And it might even talk about, well, let's try 2 alternatives here and then figure out which one we should go with. Or after analyzing those 2, it helps you maybe get a mix of the 2 or come up with a third thing as we go with that. So it's okay to qualify the roadmap. And it says, when should you think about this? These important things. Now, for example, this is an example I created to illustrate this. Because of my NDAs with most of my clients, I can't show you a real roadmap, but you might think, are there certain architectural risks, for example, that where we should think about different architecture performance or things. When should we address some of these risks, maybe with the security or other types of performance things? So it's important to add that to your roadmap. So now we've thought about the reference architecture. And we figure out we're focusing on how to deliver values. There's pressure on the team, and the time to explore different solutions becomes more limited. We've looked at the critical areas. We've planned for responsible moments. So now we need to kind of start figuring out, is everything that we have good enough? And therefore, without spending too much time up front, Agile teams have to define enough low-level details about the architecture to validate the decisions we made up to this point. So before going too far, it is critical to validate our reference architecture and which frameworks we're using, and is it going to meet our requirements? So here we're trying to look at how to put things more concretely. How do we choose this? And that's what we call tracer bullets. And by the way, tracer bullets can also guide the choice, because it might give you feedback that you need to adapt your plan as you're planning for responsible moments. And so what's really going on here is we select the smallest set of our user stories, which are architecturally relevant, that shows kind of the system running, and we implement them as a baseline for upcoming functionality. This implementation is called our tracer bullet, which is a working skeleton of the system. We use this skeleton to validate some of our architectural decisions, to make sure they are okay, and to guide future development. This implementation helps the team look at and address technical challenges at the beginning of the project. And so the architectural relevant user stories should implement real user requirements enough. And it also starts creating a template and an outline of what future teams are going to be using for development, so it can be a good influence on what's going on as we're going. So up to now, we've discussed practices for starting new projects, such as climbing on the shoulders of giants, which helps us choose our reference architecture. We then noted where it hurts, which outlines areas of risk or where the reference might need help. From this, we plan for responsible moments. Finally, we discussed using tracer bullets for verifying our reference architecture. Although this is a good start, there is more that can be done early on to help give us more confidence while we build our system. Most Agile projects include test automation specifically to validate what's going on. So to define how tests should be created, it's good to build test architecture, build into your architecture a way to test and validate up front and automate as much as possible rather than later. This can be very difficult to refactor your system later. So we're kind of building the architecture so that we can test and validate the user requirements and the architectural requirements as we go. And this can also help validate your tracer bullets, so they can work together. The tracer bullets can be used to build your test architecture. Test architecture can help validate that what you're building is good and you have a good test architecture. So it is desirable that the same test technique and approach be applied for similar architectural components. Some kind of components are hard to test, and they'll require experienced developers develop a test automation solution. The initial architecture solution for a component may not be suitable for test automation. When the tests of several similar components follow the same approach, it is easier to reuse code among them, making the next test easier to create, read, and evolve. So by doing this, you're really kind of setting you're setting a good baseline for the future development teams to use as you're going with this. So this test architecture allows teams to develop and evolve this. And when deciding on it, teams define the tests that will be developed for various parts of the system functionality, including the approach, the structure, and skeleton of the test. So you're really kind of setting the norm for future teams. And so this is a very powerful thing to do as we go through here. So although these patterns presented so far are useful when starting new projects or architecture, you can also apply these patterns during the project. To summarize, I presented patterns that focus on architectural patterns to be performed in the beginning of an Agile project. Although they can be used, you could, as you're going along, you might have new things come along and you might want to come back and look at, are there other references or other areas that help, or can we build some new tracer bullets or adjust our plan? And we started by climbing on the shoulders of giants, looking at risky areas, making a good plan for dealing with the risk, and it's an adaptive plan, and then building a working system and validating it with tests as we go. So now that's the first set of patterns. So now let's extend this and look at some patterns that we can do as we're going on through the project. And remember, although you've done, although these are up to now, you can do these throughout the projects. So the initial focus, when you're ready to start delivering value and start working on the project now. And Agile projects usually start by implementing architectural features that support backlog items that will be delivered in the first few iterations. The initial focus is on delivering functionality as quickly as possible to get that feedback. Most likely, the architecture will need to change to meet the evolving software requirements. Even with legacy software, it can be useful to consider activities for improving the existing architecture as you incorporate new functionality. So often tasks related to architecture are deferred and given a low priority, if at all. So it's important to think about this as we go. So the next pattern we want to look at here is now we're starting to develop it. And so new architectural requirements will come up. And so it's important to put architecture in your backlog as we go. And what's really we're talking about, team, how can Agile teams adequately evolve the architecture to best meet the changing stream of software requirements? One way Agile teams do this is they address these issues is to include architectural in the backlog. Yes, we can do that. So while evolving the systems, Agile teams add new architectural capabilities to the backlog to ensure that they are prioritized and implemented at the most responsible moments. It is valuable to know what should be implemented and when in the architecture, and be sure that it's implemented according to clear priorities that meets the best priorities of the business. So these are business decisions that happens at. So you can add backlog item for technical debt and quality related architecture work as you go. And so that can be part of your plan. And in fact, there's different approaches for adding architectural work items to the backlog. They can be added as independent items associated with specific user stories, as acceptance criteria, or even maintaining a separate architectural backlog that supports a functional user story. Each approach has its own benefits and drawbacks. One way to make architectural tasks stand out is to do like what Philip Crutchins talks about here, is to colorize your backlog with different colors. For example, architectural features, including quality-related items, can be colored yellow, and technical debt might be colored black, whereas your normal visible features, green is for it's good, and red if there's kind of some defect with that. But the main thing is to prioritize and put these items on the backlog as we go. Now, there's the old famous quote that premature optimization and premature abstraction are kind of your top problems that happen in a lot of software development, and it can generate a lot of unnecessary work and add complexity to future tasks. So attempting to improve some aspect of your design might not have the payoff that you expected. However, it's important to keep the architecture in sync with and supportive of your evolving requirements. So you want to focus on implementing user functionality while at the same time adequately evolving your architecture. It can be difficult to predict when you need to shift emphasis from implementing functionality to working on improving your architecture. So being aware of architecture considerations is important. However, you do not want to waste time worrying over things that might not be relevant. So how can Agile teams know when to rework or evolve the architecture? This is solved by proactively defining conditions that trigger architectural investigations, which may lead to adding tasks to the backlog. We call this architectural triggers. These triggers can be based upon values of certain system qualities that are either getting critical or no longer being met. For example, maybe the latency doubled, and we want some event trigger that notifies the teams to investigate why are things slowing down so much. So we create these triggers, and these triggers are conditions that cause you to inspect things. So some triggering conditions can be hard to quantify. Therefore, there should be an agreement by the team on how to determine how these hard to quantify conditions should be triggered. And these should be made visible to the team. And so it could be that it's still okay, but performance is moving in the wrong direction. So before it gets so bad that it's affecting our business, maybe we should do some investigation during the next few sprints on this. So you might have some discussion between the business team and developers to determine what's acceptable that you want to deal with. And you might have a system quality dashboard or some kind of radiators for doing this and making these visible. These are really focused on, they have broad system impact, not just like, oh, there's this little bit of code smell because some methods are getting too long. Now, you might be looking at the overall system. The code is becoming very muddy and entangled, where it's going to be harder to add new features. So that's maybe an architectural trigger that we look at. And these triggers can be based upon a lot of different qualities. So going on with this, ultimately, we have to deal with even more with this. So sometimes some architectural tasks are difficult to understand and to estimate. It can be hard to figure out what it's going to take to build something. Even if you have information about similar efforts from other teams, you still might be misled. So as your software is deployed and put to use, your initial architecture may have different problems scaling or evolving to some of your needs. Originally, maybe the architecture was perfect for your needs, but your company has evolved as you're ongoing, and you might need to adapt. So as you're continuing to have success, you might need to deal with some of these challenges. And so when Agile teams discover that the current architecture is inadequate, they do not know how to address it, they can add an architectural spike, which is a task added to the backlog to perform some study or investigation that supports architectural decisions. The main goal is from an architectural spike is to provide information for an architectural decision. And should we evolve the architecture or maybe even get a new reference and things like that? So as you're dealing with an architectural spike, by the way, that might add new tasks in the backlog as well. And the result of this architectural spike can be a solution, but maybe not. Sometimes it reveals that a potential solution is not viable or that the cost of risk. So it could be you have a team go off during one sprint or a couple people experiment. It should be bounded in time. And sometimes it might come up with, well, maybe we need to, separate out the database more. It could be that maybe now we need to evolve our reference architecture or update. And it could be that, no, we just need to kind of evolve some of our practices with what our teams are doing as well. So it's really, the outcome is evidence of support a decision of something that may feed back into the roadmap. So it answers these deep questions. It's not like an extreme programming XP design spike. It's more from a bigger picture, from an architectural decision, and it's visual and bounded. So you may say for the next day, these two people do that. Or maybe we have a team that goes off for a week or maybe a sprint, whatever that is from that. And you go and try, and maybe you're comparing two different things. And maybe you hire a consultant to come in and help work on you on this architectural sprint. It's important, though, to limit the time, and it can help you with your plan as you're going. Now, as we're continuing on, is to be aware of any problems coming up with the architecture. It's important to keep the architecture clean, or you're not going to be able to sustain for the long term. You might be able to sustain for the short term, but there are things that can impact you for the long term. So doing technical debt management is key. And by the way, technical debt management might also have you put architecture at tasks into the backlog as well, such as cleaning up some different technical debt, maybe some dependencies or other issues that is affecting the architecture that you might need to refactor as you go. And the technical debt is a term coined by Ward Cunningham, and anytime we're working with systems, we're creating a little bit of a mess. But if you don't keep it clean as you go, it can cause problems. And what Ward Cunningham talked about with technical debt is debt piles up when you continually implement without going back to reflect new understanding. And it can have long-term costs and consequences if you put it off too long. Sometimes it's the right thing to do. It's intentional for short term. It's tactical. You say, well, we need to get this out there to hurry the software along, to strategically and proactively take it for business reasons to get that feedback. Other types of debt might be unintentional, sloppy work practices or mistakes. Or maybe it's because people don't understand the architecture properly. So it's important to make this visible. And there's even things like test debt or quality debt. So accruing some technical debt can be prudent and even desirable, but you need to balance the cost of making any design improvement. And if we're going to clean up debt, it has to focus on the business value. Is this changing and causing problems? So you may consciously decide to take on some technical debt in order to learn something about your system and its use before improving your design. But technical debt can compound over time if it's not managed. So it's important to manage it. And quality is a pillar of agile development. And qualities are usually described as ilities or non-functional requirements or quality attributes. But qualities can also focus on how well functional requirements are met. And there's the obvious ones that people think about, such as reliability, availability, scalability, security, and performance. And they're kind of ility because a lot of them end in English anyway as ilities. But there's these other ones that help you for sustaining your software that often get overlooked. And they affect your development philosophy, such as maintainability, evolvability, testability, and deployability. So it's from these types. It's very important to kind of think and address these types of things as we go. So a lot of time when you're working with the product owner or from the business side, it's like, well, yeah, okay, testability is good, but look, I need to worry about what the customer wants. But from a development team and from the business decision, if we want to sustain our development for the long term and continue having quality software and sustain the development at a good pace, it's important to address some of these. And if we don't make it visible, how can you improve what you cannot see? So it's important to make things visible, and visible is key. And it's a big part of what those agile values when you think about that. So Alistair Coburn talks about having these radiators, and we talked about having quality radiators. So you can't fix what you cannot see, and transparency is a key part of agile. So you need these quality radiators to make things visible of what's going on with certain qualities. And in fact, this was such an important pattern. I recently, I'm a co-author on this Scrum book, The Spirit of the Game, which is trying to get the most out of Scrum. And we have 96 patterns with 2 pattern languages. But one of our patterns was talking about these information radiators. Now, I like physical artifacts, but you can even think of digital artifacts that we're displaying up physically somewhere. So electronic can also be physical. But it's important to have that information and make it transparent. That's part of our agile core value when we're thinking about that. And so as we're getting these different things, it might affect different qualities, and we might have to make different architectural decisions. So you might even have a technical backlog. It should tie into the business values, and it should be part of the business backlog. And we should make sure that the business people understand the issues that we're having from the technical side, and vice versa, that the technical people understands the importance of the business. And this should be a real collaborative type decisions when we do this. And this is transparency from both sides. So besides these patterns, as you're going on, continuous inspection can also be included as part of this pattern collection. Continuous inspection is where you use available automated tools or techniques. It kind of helps keep things visible to continually inspect the code, the overall health, and point out any architectural or code smells that are detected. These tools can be executed locally on the developer's machine or by having the system communicate with a continuous integration server that builds the code at specific times. I've worked with some different colleagues and we've written a little bit about this, but really continuous inspection is looking at maybe even the running system, what problems are going on. You might be analyzing source code, but it's not only for developers, but you might, if you have architects or other team leads, they get the information, but this should be the business people as well. So you may, everybody thinks of Sonar Cube or PMD, check style or find bugs, but there's other types of tools, and you might even have to build some custom tools to give you this analysis. For example, maybe you have a persistent layer and you want to make sure everybody uses the persistent layer so there's no SQL injection for security reasons. As a new developer, I may not be aware of that. You've hired me to come to your team. Now I bypass that. So maybe you have some kind of tools that analyze, and then it helps educate me as a new member of your team to use that persistent layer. And automation is key for a lot of this. Even with DevOps, this is becoming very important. And I love this quote by Bill Gates. He says, the first rule of any technology used in a business is that automation applied to an efficient operation will magnify the efficiency, but it also, if it's inefficient, it'll magnify that. So therefore, create an environment and use tools to automate fundamental things that add value as soon as you can. Do not put off automation until late in the development, because then they become too hard and difficult to go back and try to refactor. So if there's regular things, error prone, involves waiting, different qualities, architectural qualities and architectural conformance, automate that as soon as you can. So that's the set of patterns. The ones in blue are the ones that for starting the project. The ones in green are that you do during the project. So while being agile, it's important to have a sustainable architecture that is able to evolve through the life cycle of the project. Sustainable architecture requires ongoing attention, especially when there's evolving priorities, a lot of technical risk, and many dependencies. So what I presented here is a set of patterns that focus on practices for creating and evolving your architecture while being agile. These practices includes a set of tools which allow teams to define enough architecture in the beginning of the project and manage the state of the evolution of the architecture as you evolve. We build on a reference, we find where it hurts, plan for responsible moments, then we validate by building kind of a working system with their tracer bullets, which might evolve the plan and might evolve the reference. And then we make sure we can validate it with tests. That builds the foundation. And then as we're going, we keep architecture in the backlog. We have different triggers to let us know when we're starting to move away from our desired software qualities. And then occasionally we have to do experiments, and we manage our technical debt and keep things visible as we go. Ultimately, the goal is to have a sustainable architecture and start the project fast. And I want to just finish in the last few minutes here to talk about a couple other things for sustainable architecture. So I'm probably best known for writing the Big Ball of Mud paper more than 20 years ago. And we were never proposing to write muddy architecture. We just said that good or bad, a lot of successful systems are pretty muddy. And why is that? And maybe if we acknowledge it, maybe we can manage it and keep things, make our code, as Richard Gabriel says, more habitable, so we can evolve our systems as we go. And one of our first patterns in our Big Ball of Mud paper is maybe we need to kind of create a layer or facade to keep the mud from getting out of control, so that protecting systems as we go. And then we had our shearing layers pattern, and we related to how buildings learn, is if we separate what changes from what doesn't change, it can really help things evolve a lot much better. Just like as a building, you're not going to change the site or your plumbing as much as maybe you're going to change your room configurations or the walls in a building. Same way on our software system. So factor your systems so that the artifacts that change at a similar rates are together and they can change. So your reference and your core type of programming languages and things, that's going to change more slowly than maybe the like the platform and stuff. Whereas the code you can change quickly, and the data obviously the quickest. And one of the patterns that Rebecca Worsbrock and I wrote up for sustainable architecture is put a rug at the front door. So maybe you have a clean system and you want to keep, it's just like coming into a house. Maybe I have a place where I need to take off my boots and, adapt and clean things. And so you can wipe your feet at the front door by maybe filtering and cleansing. So rather than muddy up our internal components to handle with all these different services from all these different clients we have, maybe instead we create like an adapter, proxy, or facade, some front door wrapper to keep things clean as we go. And then we also had one for paving over the wagon trail. If you have repetitive tasks, streamline these repetitive code tasks and make them easier, sometimes with the framework and other things. So agile values can drive architectural practices. Do something. Don't debate and discuss it too long, but do something that buys you information, improves your architectural ideas, and reduces risks, making it easier and make it testable. Prototype realistic situations, and incrementally refine your architecture, adapting your plan as you go. Defer architectural decisions that don't need to be immediately made, but plan for responsible moments. So pause points helps. If you want to improve things, you definitely need to not overload yourself. So you need to have ways of having a little bit of slack time. Don't overload yourself. Spotify knows this. They have this think it, build it, ship it, tweak it. So those of you doing the Spotify model, if you continuously tweak it, you might be micro optimizing, but sometimes you have to stop, rethink it, and maybe you come up with a much better way of doing this. Tom DeMarco talks about this with, you should never be trying to just go fast all the time. You should never try to be 100% full. You should never be more than 80%. The biggest thing you'll get out of this book is learn from slack, is getting past the burnout, busy work, and the myth of total efficiency. Innovation requires slack. Full should never be the goal. Fail and learn with confidence. And so overtime is dangerous. Daniel Kahneman talks about this as well. Velocity does not equal productivity. I can be going very fast in the wrong direction. So we really have to think about value. So there's our patterns for when you start the architecture, once again, and when you finish it. So I started out this talk, this presentation here is saying values drive practices and regular practices have patterns. So I want to ask you, what do you value? Do you value building quality systems? Do you value learning and trying to get better, sustainable development? Do you value good architecture or clean code? What are your values? What are your agile design values? Mine are, I want to continuously learn and inspect and adapt and work and do the best thing possible. I don't want to get stuck. It's easy for me to get stuck. So being part of that teamwork. So I want to just say, mutuo obrigado. Thank you very much for this. I want to at least save a few minutes in case there's a question or two. There's my contact information. And then I have a couple quotes. So if you think good architecture is expensive, try bad architecture. That came from our big ball of mud. And then also, you can't fix what you can't see. So it's important to be transparent. By the way, that's a picture of me in Porto de Galinhas more than 10 years ago. I need to get back there, and I'm hoping to be in Brazil. And by the way, this is a typical spread on something you might see at Thanksgiving dinner, and that's some food that'll be waiting for me real soon. So thank you once again. And there's my contact, and I hope people found this useful.
Thank you, Joe. Thank you very much. It was an amazing lecture again. We have a couple of questions. The first one is from Felipe Emidio. Thank you, Felipe, for the question. His question is this: for a really small team, 2 to 3 developers, where do you think should we start to improve our quality in a running project? I think it's a very, very interesting question. There's another one, but if you can enlighten us with your experience on how to implement this in small teams, that would be amazing.
Yeah, one thing I will say about small teams, you have the benefit of being well, you're close, so it's not like you have a lot of the communication level is a lot smaller, so it's easier to kind of focus on that quality. So working together, for example, sometimes you do pair programming, so and so developers can work together. If there's only two or three, focusing on quality and looking at things as you go, but it's a lot easier to kind of make those types of plans as you're communicating. A lot of problems is when things really start to grow and you have many teams, or 20 develop or 100 developers, or like Paxaguru, thousands of developers now. And I think they have, I don't even know how many teams, but I bet it's more than 1,000 now at this point. you know so when you're trying to do that kind of communication, oh my goodness, paying attention to quality is important. I think it happens more naturally with two or three. So the main thing is those people keep communicating and communicating regularly. I think that happens almost naturally with small teams because you're almost working together. And before the pandemic, we'd definitely be in the same space, and hopefully that gets back to for some people with doing that. So I think it's easier to do with smaller teams, but mostly to talk a lot and communicate and be looking at what's going on with each other's code. But I think it happens naturally.
No, that's great. I have another question. That's from me. I think I mean again, I found it an amazing friend. For me, I have a lot of takeaways. I love some quotes like, implementing sustainable architecture enables us to deliver functionality as fast as possible. This is like the holy grail of business. And another one which I really love, you cannot fix what you cannot see. That's really another really amazing quote. But my question is this: for me, it's clear that agile teams, they are more productive, they are more creative. They, in the end of the day, can deliver more value. Now, I tend to think it would be a mistake for a junior developer to think, these architectural decisions, these things, they are responsibility of the management, of the CTO, of the leader of my technical organization, and I should do nothing about it. I mean, these are kind of upper management decisions, technical decisions, and I I suspect that it is much more of a team practice than anything else. My question is, what is the role of the software engineer, the junior, the mid-level, the senior, in developing this scalable architecture? Because I tend to believe everyone has a role to play in making this happen. Can you help us in understanding this?
Sure. And by the way, thank you for bringing that out. That is so important. And everybody's responsible for quality. Quality should be built in from the beginning. And I'm amazed sometimes when I go to large organizations where a junior developer feels like, wow, I'd like to influence it, but look, I don't feel empowered. This method's getting long. Should I refactor it and extract method and rename it, make it cleaner? Yes, you can. But a lot of times they don't feel empowered. And so everybody's responsible. So a lot of times, if the senior people are getting sloppy and just every time they have a new feature, add a new parameter and a new case statement, then the codes and the architecture starts becoming muddy, harder to change. So it's really everybody is responsible. That's why I like that visibility. So it shouldn't be mandated from the top down. Obviously, we want the top people to part of it, but everybody's responsible. And so obviously the senior developers need to set a good bar. And that's why some of the architectural patterns said, let's think about important architectural decisions. Let's build test in and let's build a good working template. We called it the tracer bullets early on. But that could, and as the team goes, there should be constant feedback. That's where that continuous inspection should go on. And the junior developers may come up with new ideas and challenge me where I'm stuck as a senior developer. I need to be unstuck. And so when they're questioning me and I'm like, well, this is why we did that. And I'm trying to explain, but then as they're questioning me, I'm like, but yeah, maybe we could do something different. We need to evolve this. And they should feel empowered, not only empowered, it's their responsibility. Everybody's responsibility for quality through it. Just like when you think of lean, TPS, Toyota Production System, anybody on the production line, I've been there in Toyota in Japan, can hit the stop button and stop the production because there's a problem going on here. Anybody that's working on that line can say, wait, there's a quality problem right here. And that should be the same way what's going on. If there's a problem, even if you're a junior person, there's maybe either you need to, maybe you're misunderstanding, so you need to understand better, or maybe there is a problem and we need to go back and rethink. Maybe we need to evolve and add things. It's a team effort, and that's where you have regular team collaboration. And you know, it should be, you know, everybody has feedback in that. So thank you for bringing, everybody's responsible for quality. And yes, the junior people can also write good code and clean code up and refactor something that, oh, Joe Yoder did this, so I can't change it. Yes, you can. I haven't been there for a while. You see something new and add a new feature, make it better. It's just like being at a campground and I went there and somebody left a little mess. I should pick it up while I'm there if it's no more energy to do that. So thank you for bringing that, by the way.
No, it's really amazing. Joe, unfortunately, our time is up again.
Yeah.
Thank you so much. Thank you so much for a very inspiring lecture. I love to listen to you because I always learn a lot. And we hope to have you with us again soon in the future. And
absolutely,
probably, hopefully, somewhere in the near future in present. Right?
Yeah, I plan on coming to Brazil next year for sure. The vaccines are going well here and there too. And muito obrigado. I would like to say sextou, but it's not Friday. But I will say instead, valeu. It was awesome at Legal and show de bola. You know, so thank you muito obrigado. Thank you very much for everything, and I hope people enjoyed it. I look forward to not only seeing you online, my good friend Carlos, but I hope to see you in person next year for sure. So thank you.
No, thank you, Joe. And obrigado a todos. Foi mais uma vez um prazer, sempre um aprendizado muito grande ter o Joe com a gente. Antes da gente encerrar, eu queria deixar um último recado, tá? Gostaria de informar que a gente está nos últimos dias da nossa Black Friday. A gente tem vários cursos que têm descontos de 30% a 40%. Todos os nossos cursos, especialmente o Becoming a Modern Software Engineer, Monolito aos Microserviços e o Refatoração e Testes Efetivos. São 3 cursos que tocam em cima de vários pontos que o Joe comentou hoje. E como a gente acabou de falar, é uma prática de time que deve ser aí dominada por todos em times de ponta, né, de desenvolvimento de software. Nesses cursos, a gente tem o prazer de ter o Joe como instrutor. Então, o que eu posso dizer para todos é não percam. Né? Nossos cursos são focados em capacidades desenvolvedores para atingir um nível de maturidade muito mais alto e conseguirem, assim, conquistar todos os seus objetivos de carreira nessa carreira muito bacana, que é a carreira de engenharia de software. Então é isso, pessoal. Mais uma vez, muito obrigado. Thank you again, my friend Joe. And,
thank you. Black Friday. That's tomorrow. Ciao, ciao. See you.
Ciao, ciao.
Bye-bye, everybody.